All right, so today we're going to talk about the last of the four pillars of object-oriented programming, and arguably it's the most powerful among all the things that you can do with code, because basically you can write code to that you can be applied to multiple different types. Polymorph simply just means multiple forms, and in code that means that one piece of code, a variable or a class or even a method, can be written generically so that it can be applied to many types. Every programming language has something like this. In Python, for example, you have one sort method, right? You can sort this list, and whatever's in it, it'll take care of it for you. In C, we have qsort, right, where you pass in a comparator and you have a generic void pointer. It can point to anything. It can point to an array of doubles, an array of integers, or whatever. And in Java, we've seen the collections.sort. That's polymorphic because it can be applied to any type. It could be applied to a list of students. It could be applied to a list of integers. It could be applied to a list of bank accounts, right? It doesn't matter what you're sorting as long as you tell it how to order things with a comparator. It allows you to write generic code so that one function or method can be applied to any type, or to multiple types, I should say, not just any type. And we've seen one of these already. We've seen subtype polymorphism. And this is known as the classic, or whenever somebody says polymorphism without a qualification, that simply means that they're talking about this default subtype polymorphism. All that means is that you can treat a subtype as a supertype. Okay, we've done this multiple times. For example, you can take a robin and you can treat it like a bird. You can take, you can take a dog and you can treat it like an animal, right? But a much better example is that you can take an array list, like we've been doing, and you can treat it as a generic list, okay? Why? Because we've got this, now this is the simplified version of the collections hierarchy, but it's organized roughly like this, where you have an array list down here, and that's just one type of list. It inherits from this list up here, which is a generic list. It holds stuff in an ordered manner, right? How does it hold stuff? Well, the array list uses an array. A linked list, which we'll look at much later, uses a series of nodes to store things. So it does it a little bit different. But they're all collections, just like sets are collections. And there are multiple types of sets. Generally, what you want to do is you want to treat it as the most generic as possible so that you can write as generic of code as possible to apply to multiple types. We're going to take a look at example later on here, but let's take a look at two other types of polymorphism. Those coming from a C background are really going to appreciate this. Remember how many absolute value functions there are in C? There's abs, that's for integers. There's fabs for floating point numbers, labs, lullabs. Why do we have all of these different function names when they all do the exact same thing? It's because in C we don't have what's called method overloading, right? This is something that came with object-oriented programming later on, where C doesn't have function overloading, right? If you write a function, there's only that one function that can have that name, right? So absolute value, if I just go abs, then that can only be applied to integers. Python, by the way, doesn't have it either, right? Python does not have function or method overloading, right? However, Java does, right? You can write multiple abs functions, or methods, I should say, that can be applied to multiple types, right? For example, let me come over here to my demo, and let's go ahead and say that I've got an int x is equal to -10, right? And I want to take the absolute value of that, math.abs. Well, we've got lots of abs here. We've got one for doubles, we've got floats, integers, and longs, right? We've got 4 different versions of this thing, and then 2 others that have abs in the name. They have 4 different types, right? So which one should I call? I'm not even going to bother, right? I'm going to let the compiler take care of it for me, right? The compiler is smart enough to say, oh, you're calling the absolute value function. There are 4 of them. Which one should I actually call over there? Okay, you're passing an x. X is an integer. Therefore, you must have meant to call the function that takes an integer and returns an integer, right? What if I change my type up here? What if I said that now x is a double, right? The compiler is smart enough to see that, well, that's now a double, and so therefore it calls the absolute value function that takes a double and returns a double, right? that is called static dispatch. And it's not static like this static keyword over here. It simply means that the compiler takes care of it for you at compile time, right? And that's what's called a function overloading, right? Again, you can have more than one function that with the same name, but with different types, that is inputs or parameters. The compiler is smart enough to determine which function you actually meant to call at compile time. This mechanism is known as static dispatch, right? A dispatch, like a cab dispatch. Go out to that location because somebody needs to be picked up, right? And a compiler dispatches the function call at compile time, and that's what static means in this case. It's not static as in it belongs to the class. It's static as it means that it is at compile time. The opposite of static would be dynamic. That's at runtime, right? When the program is actually running. And that brings us to operator overloading, right? Or function overloading as well, right? So consider Java, right? If I took a string and I said plus, right? That means string concatenation, right? What if I did the following? What if I took an int or a number or whatever, and I did, let's go with lowercase int, or integer. Let's do that, lowercase int. And I did plus int. Now, how would you interpret that? How does Java interpret that? Is that string concatenation anymore? No, that is addition. Right? What if I mixed them, though? String plus int. How is it going to interpret that in Java? It's string concatenation. What it'll do is it'll convert automatically, the int to a string and do concatenation. Yay, I really like that. Right? What about C? Those coming from a C background. What if I did a int plus int? That one is pretty straightforward, that's addition. But what if I did a char star? For those not coming from a C background, char star is a pointer to a character, which is C's way of doing strings. What if I added two char stars together? Right? That has a meaning, right? But it's nonsense, right? It adds two memory locations together, right? And there's no interpretation there. Those from a Python background, what if I asked you the same thing? What if I had a string plus a string? Right? How would you interpret that? As concatenation, right? Right? What if I did an integer plus an integer? Right? What's that going to be? Addition. Right? But now here's where the gotcha, right? Do you know Python or not? Right? What if I did an int plus a string? Right? What's going to happen in Python? Crashes, right? This is not allowed, right? It is a runtime error, right? What do you have to do? What do you have to do to that string to get it to work? To get it to work, what do you have to do to that, or what do you have to do to that integer to get it to work? You have to wrap it up in str, and then you can go ahead and concatenate with a string, right? This is what's known as operator overloading, and C and Python do not support it, all right? Operator overloading means that an operator, say for example plus or minus or subtraction, all the built-in operators can have more than one meaning in different contexts, right? In other words, it has a polymorphic behavior, okay? Java has very limited support for operator overloading. Generally, you can go to other programming languages like C++ allows any operator overloading, right? That means that, there we go. That means that you could change the plus sign to mean whatever you want. You could change the plus sign to mean subtraction, right? That's weird, but it is allowed in C++. Why this is generally a bad idea? Generally a bad idea, right? What if I had time plus time, right? In other words, like 10:39 a.m. plus 5:36 p.m. What does that mean? Does that have any interpretation? Or maybe you could say, oh, well, that means 10 hours and 39 minutes plus 5 hours and 35 minutes. That gives you, 17 hours and some minutes, right? Okay, fine. What if you did list plus list? And by the way, this is supported in some languages, in particular in Python. What if I did a list plus a list in Python? What happens there? Do we remember? It could be list, concatenation, or appending. Right? All it does is takes the first list and adds it to the second list, giving you, I believe, a new list, right? It doesn't, I forget whether or not it modifies the original list. But there's another, alternative, right? Alternative, right? It could be, now some of you are in 150 or 235 right now. What does this mean? Right? A cup B, what is that? It's a union, right? Are you doing sets yet in 235? Yep, there you go. So I could interpret that as union, right? Or I could maybe think of it as intersection, right? Or if it's a math-oriented kind of problem, it could be a coordinate-wise addition. That's what it means in math. If I took a vector of three numbers over here and a vector of three numbers over here, component-wise addition would be the first two numbers are added together, the second two numbers are added together, the third numbers are added together, and then you have a new vector, right? Confusing, right? Ideally, it should have a completely understood, unambiguous meaning, right? C++ is the only language that ever allows you to do this anyway, right? So the takeaway here is that operator overloading is a thing that you should know about, right? And you should understand that different languages do different things, even for basic types like here. We've got 3 different languages, 3 different interpretations, right? But it should be extremely limited, right? Other languages don't even allow you to overload operators at all, like PHP. You would not be allowed to use plus with anything other than a number, right? In order to do string concatenation, they make you use a period instead. So here's my string, and I put a period between them, right? Kind of weird. Right? But otherwise, operator overloading, you should know about it because it is basic polymorphic behavior, but it is you should take it to be very, very limited, right? The real power of polymorphism, in my opinion, is where we've got what's called parameterized polymorphism. And you've seen this in Java already. You've used it in Java, right? But you might not have designed something in Java with it. In Java, you can create a parameterized variable, class, or method, right? This just simply means that one variable can be any type, right? It can act on any type, can be associated with any type, right? So let me come over here, and I'm going to go ahead and close this, right? And what I've got here is an array list of integers and another array list of floating point numbers that I just put together, right? Ints and floats. First of all, let me go ahead and start out with the very, very basics. Int x is equal to 42. That creates a variable of type integer, and it sets its value to 42. The value of the variable is 42. What is the type of the variable, though? An integer. Can it ever change? Can I ever say, well, now x is equal to hello? Right? In Python, I could certainly do that, but that's because Python is a dynamically typed language. This is a statically typed language. Once you create a variable of a certain type, that type cannot change. We're not allowed to do that. The type is integer. If I did say double y is equal to 3.5, right? Then the value of that variable is 3.5, but the type of the variable is double. What if I had no type at all? What if the type of the variable, type, right, and which I will shorten to t, right, was also variable, right? Okay. Well, it's not going to compile right away. I've got to do some tricks here. But that would enable me to say that, well, the variable type is variable itself, right? There's a variable, it has a value, but it has a type, but both of those things can vary depending on where you put this in the code, right? To do that, I would have to parameterize it, but we're going to learn how to do that here in a second. What I want to do is I want to show you the limitations of a world without parameterized polymorphism. I've got 2 array lists here. I want to add them up. So let's go ahead and write a basic sum function here. Public static double, let's go with it, int and sum, right? I'm going to sum up that first list, array list of, say, integers, right? And I'll call it numbers, right? And how would you go about doing this? Well, I need a total, of course. Should I just leave it like that, by the way? What, return total? Should what value does total have right now? Undefined, right? That's why it's not compiling. Right? So what should I do? If I'm going to sum things up, I should start it at 0. Right? All right, so for each integer x in the collection numbers, I'm going to go ahead and add it to the total, plus equals x. Great. Right, that works. Let me go ahead and see that it works and add these up. So system.out.println sum of ints. There. And when I run this, it's going to print out that the sum is 34. I trust it. I don't know. Go ahead and verify and add those up. Right? Doesn't matter. Can I use the same function for floats? Let's try. Floats. There we go. It doesn't compile. Why? What does sum take? It takes an array list of integers. It is only good for one thing, integers, right? Well, okay, fine. I'm going to call this a sum for ints, right? Because I can't reuse that name, or I can reuse the name because of method overloading, overloading. But I'll go ahead and emphasize this, that there's going to be a copy-paste of floats, right? Sum for floats. How would I change it? Well, I would change the type to doubles, right? I would change the return type to a double. I would change the total to a double. And I would change that type right there. Did I actually change anything of the code itself? I just changed the type, right? That tells me that there's an opportunity here, right? There's copy pasta, right? I have the exact same code, but the type is different. Well, what if I did the trick that I was talking about before? What if I parameterized the variable? Right? I said, well, no, this is a variable that has some type. It could be an integer, it could be a double, right? I don't care. I just want to sum them up. Okay. How do we get there, though? Right. First of all, I want to go. Sum for ints and sum for floats. There we go. And those will now both work. But I've had to copy paste an entire function. I don't want to do that. I want to write one function to solve this problem so I never have to worry about this again. All right? Before I do that, let's go ahead and look at another example. Right? I'll go ahead and do this right here. What if it were not an array list? What if it were that other thing called a linked list? Okay? So linked. Let's go ahead and change this to linked. Come on. List. There we go. Linked list. There we go, and bring that in, and bring that in. Ints, I'll call it LL for linked list here. And I'll add all the same ones to it. And I do need to bring this in because it is part of the Java utils library. There we go. All right. Can I reuse that sum for integers here? Oops. There we go. I thought I did sum for ints. Array list numbers. Oh, weird. Oh, that's right, because it's ints. It should be ints LL. Right, there we go. Is that going to work? No. What type is ints LL? It's a linked list. Does my sum for ints take a linked list? No, it takes what? An array list. So let's go back to our first idea of polymorphism, subtype polymorphism, right? Where I treat the subtype like a supertype so that it can be applied to multiple types, right? For example, I will treat the linked list like a list so that I can write one function just for lists. I'll treat the array list like a list so that I can just use one function for lists. Here's what that looks like. I'm going to take and move this to a supertype list. Okay? And do you see what happened below? It now compiles. I can apply that one function to an array list or to a linked list. It doesn't matter. Right? I have one function to rule both of those types of lists. Right? I don't have to do a copy paste. Right? I don't have to repeat myself and violate the DRY principle. That's such a good idea. How can we go about doing it for doubles? Okay? And this is where parameterized polymorphism comes in. I'm going to rewrite these functions. Public, static, I think the order, Oops, sorry, just a second. Where was it? Yep, there we go. And then I'm going to put something here. This is, we call these Langle-Wrangle, right? Left angle bracket, right angle bracket, right? And I'm going to put a parameterization here, right? And I'm going to come back to that. That's not real yet. But otherwise, everything else is going to be the same. Double, sum, and I'm going to take a list of, say, integer, of something, question mark, numbers, right? And all I'm going to do is I'm going to copy this code over. There we go, and bring it up over there. Right. Now, what are your types going to be? Let me answer this question first, okay? I want this to apply to doubles. I want this to apply to floats. I want this to apply to longs. I want this to apply to integers. So what I'll do here is I'll say, I don't know what the type is. There's going to be a placeholder variable here called t. T is short for type. Don't type, just use t, right? Sometimes you use e's, it depends on the context, but you just need to use a variable. Now the parameterization over here, that is going to be a signal to Java to say, this is a special function that is parameterized. It can take any type t, right? And I repeat it over here. Now this is not going to work inside here because I don't have well, first of all, I need to create the total is going to be total, t here. And it's not going to be integers anymore. What are my types in this list up here of numbers? What are the types there? T, right? It's variable itself. The variable type is variable, okay? Now that will be applicable to, in fact, it's not compiling yet, but now what I can do is I can come down here and I can say, you're the sum, and you're the sum, right? In other words, I only have one function that applies to all of these situations, right? As long as I can get it to a compile. Now the problem up here is that what is type t, right? If I just declared a type variable t, y, right? Then what's its type? You have no idea. I need at least a little bit of information here to be able to say, oh, you can convert that to a number and add it to the total for me, right? So what I'm going to do is I'm going to put what's called an upper bound on this. T extends number. I don't have a diagram for it, but an integer is a number. A double is a number. A float is a number. In other words, it follows this inheritance hierarchy, right? All of those things are numbers. So now what I can do is call a method on that thing called double value. If it's an integer, 10, it'll convert it to 10.0. If it's already a double, of course, it just returns itself, right? If it's a floating point number, it will cast that to a floating point number, and so it'll just be, 10.5 becomes 10.5. It's just more bits in the representation, right? And I can get rid of that y now. That was just demonstration purposes. Right? How nice is that? Now down below, all three of these situations work. Run it, right? And I get the same answer over and over and over again. I could potentially replace like dozens of different functions that I would have to write in a world with no parameterized polymorphism with just one, and that's it, okay? In fact, I can go a little bit further, right? Is list the only type of collection? No, I could promote that up to any old collection. Oops. Collection. Right? I didn't break anything because down here a list is a collection, an array list is a collection, et cetera, et cetera. But what have I now done? I've expanded the landscape for which this function is applicable. Right? Now it can work on any set as well. For example, let me go ahead and come down here and create a hash, a set of integer, I don't know, floats. We haven't done that yet. Float, more floats, right, is equal to new hash set of the same floats. I'm going to have to import those things. Import, there we go. Import, come on. Save it, there we go. Hover, all right, fine. I'll just copy, paste, and set. Oops, set. There we go. All right, and I've got my floats there. So more floats dot add all, and I don't know, I'll just go ahead and grab all these same numbers over here, or at least the first four of them, right? List of, there we go. I can't add all those. Add? No, it's not gonna let me do that either. All right, fine, I'll just do it manually. 3.5, more floats. Why can't I add? Oh, it's not a floating point number. Here's a trick. That's a double technically by default. So in a lot of programming languages, if you want the lesser float variable, 32-bit float, you have to put an F after it, and that's why. Otherwise, the code that I was using before should have worked. 1 and then 5 there we go. I can still call the same sum function here on this more floats, right? And run it, and it will still work, right? Awesome. I have one function now that is as generic as possible. It can be applied to any collection of numbers, okay? That's the power of parameterized polymorphism, right? So in sum, let's go back over here, right? There we go, right? It allows you to write one piece of code, for example, collections.sort, that it can be applied to many types so that you don't have to worry about, you know, writing, cutting, pasting, right? The variable, or the type of a variable can be variable itself, right? You can parameterize using, say, t, right? Then t, I'll do it like this, t is replaced when with an actual type for each method call, right? You can think of it that way. It's not exactly how it works, but that's the idea. In other words, what is t at this point? Well, when I call it for an array of integers, well, that t becomes int. It's like it gets replaced. This is a collection of now integers, right? And this t gets replaced. This t gets replaced. You can think of it like that, right? Let me roll that back though. When I call it a second time on a bunch of linked list of double, or an array list of doubles, that t gets changed into a double, right? That's the way that you can think of it. Okay. You can provide bounds. Oops, sorry. Let's go back over to the notes. You can provide bounds by using the extends keyword. All right. And why would you need to do this? Without a bound, the type t is only ever an object. Right? That's because everything in Java is an object, or it belongs to an object. Right? In fact, if you keep going up the inheritance hierarchy, you will eventually get to object. For example, let's take a look at what an integer is. An integer extends number, right? Well, what is number? Let's take a look at that. That's an abstract class. It implements serializable, et cetera, but implicitly above it is an object. Let me go ahead and get rid of both of those. Come down here, and let me show you what an object is. Oh, there we go. Well, what is an object? It's just a generic thing, right? Everything in Java inherits implicitly from object. Why? Well, some things will start to look familiar if you take a look at the actual implementation here. What does the object define? Hashcode method. And after we get back down through all the documentation, an equals method. What is the default behavior of the equals method? It's just asking whether or not they're the same thing in memory, right? And then what else do we have? I think there's this clone, but don't worry about that. There we go. What does every object have? A toString method. Does it look familiar? Get the class, get its name, put an @ sign between it, and then take this hash code and convert it to a hexadecimal number. Right? If I don't define my own toString method, that's the behavior I get. Right? It's the qualified path name with the @ sign and then a hexadecimal number following it. Right? I think we've done it for bulk and a bunch of other things, right? These are all parallel and distributed computing kind of things. Wait, interrupt, et cetera, et cetera, et cetera. Those are all internal, right? But otherwise, it doesn't actually define a lot, right? So if I only had information that it was an object, could I add them up? Let me try. Public static, without the parameterization there, double sum for objects, right? And it's a collection of whatever. I'll go ahead and go with object here, right? Object, stuff, right? So what could I do with stuff? Could I iterate over it? Yeah. I could say, let me grab all this code here, right? And there we go. There's my object, right? In my stuff, right? But what could I reasonably do with it? Does the object have a double value? No. What does that mean for a string? Can you convert a string hello into a double? That doesn't make any sense. Can you convert a book to a double? No, that doesn't make any sense either. So what is the only information that I have here? X dot. That's it, right? Those are the things that are defined in the object class that we just looked at. Equals, get class, hash code, notify, toString, and the 3 wait methods there. Right? In other words, I don't have enough information to determine what can I do with this stuff. I could print it out, right? I could say system.out.println x.toString. That's about it, though. I could not compute a total at all. Right? So there's all you can do if you don't have a bound, right? Without a bound, you only ever know that you have an object, which is limited to toString, right, etc. I'm not even going to go through the rest of them. With a bound, you have a minimum of information. Right? That means, for example, over here, if I know that t is a subtype of number, all numbers have this double value method here. Okay? And so I can sum them up. However, does a string have a double value method? Let's find out. Do I have any strings? Let's go with string s. Right? And it's going to be way easier to just do it like this, s dot. Try and look as hard as you can. There is no two double method here, right? Because that doesn't make any sense. Could I take a book and convert that to a double? No, that doesn't make any sense either, right? So it limits you to only things that are numbers. Let me show you that you can't do that anymore. Do it with a set of strings. Names is equal to new hash set, right? And names.add, and say John, right? And whatever else you want. Can I call that sum function? Sum on names? No, right? Why? What does the compiler say? The method sum in the type poly demo is not applicable for those arguments. Why? Because a string is not a number. Right? It doesn't follow that inheritance hierarchy there. But could I call that other thing? What was it? What did I call it? Not sum, but sum for objects, right? And I'll rename it here in a second. But yeah, you can go ahead and call. Oops, not that way, but this way. Sum for objects. You will be able to call this once I resolve the compiler error there. I'll make this into a void function. And also, it's not summing anymore. What is it doing? Print all. Right? Let's go ahead and go with that. Okay, that's a better name. Okay. And can you call that function on a print all? Yeah. Oh, come on. Why not? Oh, set of strings. It's a collection of objects. Yeah, you should be able to do that. Change the method to, nope. Change the type. Okay, I can change the type, I guess. What I could do here is I could say that this is now a set of objects. This is not how you should do it, but you can. Oh, come on, you can't do that? Fine, I'll just do it up here. Set of object. There we go. Now it works, right? The other thing that you could have done is you could have gone back about, I'd say about 20 years at this point, and gone to a Java that did not have parameterized polymorphism. This is, I mean, historically speaking, a relatively new thing in the last 20 years or so. Java is like, 30 years old now, right? So this is only 20 years old. And if you were working with Java back in the late 90s, this is what you had to do. There was no parameterized polymorphism, right? There was no langle-wrangle saying that this is a set of integers or this is a set of strings. Instead, this is just a set of stuff. It is a set of objects. Right? So that's not a very good world to live in, because then you end up having to write and rewrite a whole bunch of stuff. Or what if I could do this? Names.add 10. Right? Now I've got what are called mixed types. And you can do this all day long in Python and a couple of programming languages. It's not something you want to do, though. Because what if I were to call sum on this? Pulls out my name and tries to add it to 10. There's going to be a runtime exception there. Right? You can't convert a string over to an integer. Right? So we generally don't like this. Right? Instead, we like modern Java, where we are using this parameterized polymorphism. Right? One more example that I'll leave you with here today is that you can also have what are called wildcards. Right? That's an upper bound. Then this is not something that you're going to want for your project at all. Right? Don't get too complicated here. But I do want you to be aware that it exists. The question mark here is an unnamed parameter. Right? So you can have upper bounds here of, I don't care what the type is, it just extends of type T. That'll match any subtype of T. You can also use the super keyword to give you a lower bound. Right? It is this thing or above. Right? That's not all that useful. And you can also do multiple interfaces if you really wanted to. What I want to show you is not that, but let's go ahead and jump down to, there we go. Right? The only thing that you know about stuff, if you have this wildcard here, is that they are objects, just like we saw. Right? And you can get them, you could print them out, but you can't do much more with it. You just know that it's an object. So it has a toString method, it has a hash code method, it has an equals method. Big deal. Right? But if you have a named parameter here, this T now you can actually do stuff with it. Instead of treating it as an object, you can treat it of type T. That still doesn't give enough information because I have no idea what type T is other than it's an object. I want to treat it as a string so I can concatenate it, or I want to treat it as a number so that I can add it up, right? That's where a bound comes in. And in this case, I've done an example of a bank account. T extends bank account. So this is a list of T's, not necessarily a bank account, but things that are bank accounts. For example, a checking account and a savings account. I could call this function on either one of those. Right? I could call it on a list of checking accounts or a list of savings accounts or a list of whatever other accounts that I might create in the future. I've future-proofed this by writing this one function to deal with all future types of bank accounts. Right? And then I can go further. We didn't actually use the type T, did we? Right? Did you see T here at all in the code? Nope. So we can erase it and use a wildcard here. We don't care what type T are. We just know that they are a bank account so that they have this get balance method. Right? But what if we do need it? For example, I've got a list of accounts and a new account. And if the balance is greater than 0, then I will add it to that collection that you just gave me. Right? And this is kind of a made-up example, but here's the idea. Now a question mark would not suffice here. I would have to put a type T there because the list is of elements of type T. Right? And I need to, this is all what's called producer extends consumer super. Don't worry about it. Right? Now, you can use both a combination of wildcards, question marks, and named parameters, T's, to get to do whatever you want. For example, the list didn't really care what those types were. Right? We can go ahead and erase that type there as long as we know that it's it's a lower bound on T. Right? That it's at least a bank account and it's not like an object up here. Right? There it places I get confused on upper bound, lower bound because it's like the inheritance hierarchy. If you put a bound up here, it's an upper bound. If you put a bound down here, it's a lower bound. and then you're trying to make it as general as possible, right? If you only do it for one element, then we're back to square one with no parameterized polymorphism. If you want it to apply it to as many types as possible, you expand your lower bound, you expand your upper bound. You expand your upper bound until you have no more information, or like it's now a generic object. Now we can't call that get balance method, right? And so we have to put a bound to have a minimum amount of interface. You can lower your bound for as long as you don't care about what the type is, like in this case. Right? And again, if you want to learn more about this, it's all called PEX, right? That is producer extends consumer super. And what I'll do in the notes is I'll put what that means, right? So a collection is a producer of elements if you want to pull things out of a collection and do something with them, right? Then you need a named parameter like t extends item, right? T is the type that's being used. A collection is a consumer if you want to put stuff into the collection, right? And in that case, you can use a wildcard here and then a super item, right? It's a lower bound, upper bound kind of thing. If you don't really care about what's in the collection already, you just want to put that element in, right? So it can get super, super complicated, right? For example, I don't know, let's check out the integer again. That's not very complicated, but it's somewhat complicated. No, that's not complicated at all. I know what's going to be complicated. Real elements. So collections dot get max. Come on, or max, I guess it's called max. How did they do this? Right? They did way complicated. They made it as generic as possible. Right? T extends object, and it is comparable of a wildcard super type of T. It returns a type T, and it takes a collection, which is, we don't care because it is a producer that extends elements of type T. Right? Now, what does all that mean? Right? I have one max function that I can use for any of those types. Right? Let me go ahead and bring that down. And what I could do is I could say double max m is equal to collections.max of, what were my integers called? Ints? There we go. I can do it with integers. Double m2. I can do it with max floats. What else can I do it with? m3 is equal to collections.name, or .max names. Right? And I need to make sure that they are indeed strings there again. Right? And I can get rid of this stuff now. Right? And you should work. It's a set. Is it a list? All right, let's go ahead and change that to a list. Oh, no, whoa, why are you not working? Right, it takes a collection, and strings are comparable. Max of name, I called it names. Oh, that's why, it's not compiling up there. Array list, there we go. And now it should compile down there, shouldn't it? All right, fine, what's your problem? Cannot convert from string to double. Oh, duh. All right, what is the return type? There we go. It's going to be a string, because what is the maximum of strings? Chris and John, which one of those is going to be the maximum? Which one? Remember, lexicographic. It's going to be John, right? If I put Zoe in there, then it would be Z, right? It can be applied to any type. What about books, right? Do you remember what we did with our book demonstration that we started out with a long time ago at this point? Let me go ahead and open up book. All right, there we go. Oh, I didn't do it here. I can say implements comparable to another book. And now I can take that same max function, and whatever this means for books, I can now apply it to that max function, right? They made that so generic, right? Save this. They made this so generic that it can be applied to hundreds of different types. Right? All you have to do is make it comparable and make it into an object. And you never have to solve this problem again. By the way, is there a min function? I don't think that there is. Oh, there is. Okay, there's the min function. Right? And same thing here. As long as it is comparator, I guess that's comparator, right? As long as it's comparative, there is no min function then. All you have to do is take a comparator and then reverse the order, dot reverse, and then the min function is now a max function. But that is the real power of parameterized polymorphism. What we'll do on Friday is come back and we'll talk about what are called the solid principles. And these are restatements of some of the design principles that we've already talked about or that we've already demonstrated. The single responsibility principle, the open-close principle, like what you should do and what you should not do in object-oriented programming with respect to encapsulation, abstraction, inheritance, and polymorphism. Right? But otherwise, you'll get more practice with polymorphism in Lab 6. We walk you through designing the system and iteratively design it so that you're increasing your upper bound, you're decreasing your lower bound to try to get it to operate on as many things as possible. So you only have to write one function to do something. Right? All right, I'll see you on Friday then. Remember, your assignment is due for this Friday as well.